Okay, hi everyone. Good evening, good morning. Um, Everyone joining in. Yes, hello. Keep your introductions coming on the chat. Let me know your name and the city that you're from. And people on YouTube, we're just live. So if you're watching us, just leave us a message on the live chat. Hi Meher, Joasson. Nice to have you guys. Jane, hi. Good morning. Sarabjeet, hi, good evening. Just live, so if you're watching us. Yeah, hi, Abhishek. Yeah, you can leave your introductions on the chat here on Zoom or on YouTube, wherever you're joining us from. Hi, Shri Ganesh. Welcome. And everyone else who's just joining in, quickly leave your introductions. My name is Aparna, and I will be your host for today. We've got Amitendra, who will help you understand what exactly is machine learning in a very short span of time. So you will understand, the whole concept of machine learning and what it contains, how you can upskill in the session today. That's the agenda of the session. Hi, Sai Kumar. Hi, Durgesh. Everyone else joining in from on YouTube. Great to have you guys. Hi Pratyusha, hi Manish, hi Ayu, Vimal. Nice to have you guys. Great. Nice to see all of your introductions and also, enthusiasm in you today. Great. So before we get started, just some quick ground rules. You might have questions to ask, and while whether it's during the session or whether it's related to your career, whatever that can be, just use the Q&A box for posting your questions. Remember, use the chat box just for interacting with us or the speaker or the expert here. Make sure you reserve questions and put them clearly in detail on the Q&A box, and not repost your question because, again, you are just kind of distracting the other learners as well. Yeah. So the Q&A box is open to everyone. Everyone can read, see questions that others have posted. So maybe just take a look at what questions have come in. And, if you have the same question, just wait around. We will answer your question. And people on YouTube, if you have questions, please use the live chat to post the question and then I'll pass it on here. Yeah. So if you miss something in the session, again, please do not worry. Please do not ask us to repeat because we have, limited time. So we're supposed to end the session in an hour, hour to 10 minutes. That's how long the session is. So if you miss something, do not worry. You will receive the recording to the session tomorrow. Okay. Along with a webinar certificate. Now, this certificate comes to you along with the link on your email. So make sure you stay till the end to enter your full name. Yeah. So these are some quick ground rules. So just trying to avoid you and also save your time in posting these questions about certificate and recording. Not now, Pooja, towards the end. Yeah. Now, quick information about your work experience. So all of you have introduced yourself and you've told us which city you're from. We would just like to know what your overall work experience is, and this needn't be specific to machine learning as well. So people on YouTube, please use the live chat. There are a lot of you today on YouTube. It's nice to see a lot of enthusiastic learners. So just use the live chat here. Let me know your work experience. People on Zoom, you can let us know your answers on the poll. Yeah. So there are going to be a lot of these polls today. One to ask your name for the webinar certificate. We'll also collect your interest in our courses in AI and ML. We'll also ask you how your experience has been. So there are going to be a lot of these polls launched during the session. So just make sure you're quick with your answers so that we can proceed ahead with the session. Yeah. Okay, Mehboob, I don't have the answer to that question, unfortunately, but there's anything related to the session, I will certainly pass it on. Yeah, great. Mixture of people here on in the session. So Amitendra, I hope you're able to see these results. Most of them have a lot of experience. Some of them are currently studying. Same goes with the audience on YouTube. 3 to 5 years is the average experience that our learners have. Yeah. Okay, great, great. So now that we have set the ground rules, we have understood who you are, what your profile is, let me quickly take you through what Simplilearn does. So Simplilearn offers skills in various domains, AI, machine learning, data science, business analytics being some of them. So if you're really interested in upskilling in any of the domains that you see on this slide, you can head to simplylearn.com. Now, you can also find certifications, you will find courses that are aligned to a certain career path, whether it's an AI engineer, whether it's a machine learning engineer, whether it's a data scientist, any role, you'll find courses that are aligned to helping you pursue that career path. We also have long-term PG programs, and we'll talk about the PGP in AI and ML. We'll talk about that in detail towards the end. So you can check these courses out and see which one fits your requirements and how it helps you upskill and find better opportunities, right? So again, coming back to these courses towards the end, but right now, let me introduce you to our expert, Amitendra. So Amitendra has got more than 16 years of experience in analytical and statistical concepts. He's got immense amount of experience in training. So he's the best person for you to learn machine learning from. So you will be able to understand all the fundamental concepts that you need to know before you pick up any upskilling course today, right? So he particularly trains and mentors people on AI and machine learning concepts, and also on analytical tools like Python and R, right? So welcome, Amitendra, to the session. I will let you introduce yourself and also share your LinkedIn profile on the chat so that the learners can connect with you. Yeah, I've shared. You can also introduce yourself and then we'll proceed ahead with the session.
Thanks, Aparna. Good morning, good evening, everyone. I'm Amitendra, and it's a pleasure to be here with you today. I hold an MBA degree and have over 16 years of corporate experience, driven by a deep passion for analytics and statistical concepts. Throughout my journey, I have specialized in training delivery and analytics product development and accumulating over 4,500 hours of corporate training experience in data science, artificial intelligence, and machine learning. And I have had privilege of working with esteemed organizations such as BCG, European Agency, World Bank. I have been part of Purdue University program as well as Caltech through Simplilearn. Additionally, I co-founded Intellitica, where we craft data-driven solution to solve real-world problems and drive innovation. So this is in a nutshell what I have been doing.
Great, great. Thanks so much for your introduction. I think we'll head on with the session and you can let me know whenever I should switch the slide. Yeah.
Let's start with what is machine learning, a very fundamental question that come across. Machine learning is a branch of AI that helps computers learn patterns from the data and make decisions or predictions without being explicitly programmed with specific rules. So instead of writing code for every possible scenario, ML systems find patterns in the data to determine those rules on their own. So that's what machine learning is. The main aspect of it is that it is learning without explicitly being programmed. Now, the key applications, if you see here, extract actionable insights from the vast data set. And in today's scenario, we are accumulating data with a rapid pace and huge volume of data is getting generated. ML algorithm helps us to analyze that data in no time and come up with some actionable insights, help you to predict a certain outcome, and helps you to be ready with the future action that you are supposed to take. It also allows models to improve their performance over the time without any kind of human intervention. In terms of applications, when you're talking about Netflix recommendation, you must have experienced. It suggests shows you might like, and it predominantly uses two kinds of technique. It finds users with similar taste and recommends what they liked, and it also looks for the shows which are similar to what you have already watched, and it suggests them. Another application you might have heard, self-driving car, where driver drives cars autonomously by recognizing objects and making decisions. And here, if you go into detail of self-driving car, you will realize it utilizes machine learning algorithm to identify objects like pedestrian, traffic signals, and lanes, and uses reinforcement learning to learn how to make driving decision by trial and error, aiming to improve safety and efficiency. Machine learning is also utilized in fraud detection. It detects unusual transactions that could be fraudulent, and it uses algorithms like decision tree or random forest or probably extreme gradient boosting algorithms to classify transactions as normal or suspicious based on pattern in the data. This approach allows system to adopt, improve, and solve complex problems efficiently without needing detailed programming for every situation. So instead of we sitting and probably writing rules, trying to code every possible scenario, we let machine learning algorithms go through the data, understand the deeper meaning it, and then start finding certain insights which might help us to predict a particular outcome, and we can take some proactive step. So that's what machine learning does for us, and that's what machine learning is all about. You can go to the next one, Aparna. Oh, machine learning, when you talk about at a very broad level, you can divide into supervised learning, unsupervised learning, and reinforcement learning. So, supervised learning, when we are talking about supervised learning is a type of machine learning where the model is trained using labeled data. Now, the label data is a term that you'll come across every time you hear about supervised learning. Label data is basically where you have been given some data, certain inputs, and for each input, a description has been given that what it represents, and that's called label. Like for example, we can provide an image of a dog and also maintain that there is a dog in the image. In a sense, we store that information that here is a picture of a dog. So that's called a label. So the input would be an image and the label would be a dog. So that kind of data, when you have, it's called supervised learning. And in this setup, the data includes, as I mentioned, both inputs and their corresponding correct outputs, which is called labels. The model learns how to map the inputs to the output, and once trained, it can make predictions on new data or any unseen data. Meaning, if I can train an algorithm which can identify dogs from cats, tomorrow when a new image comes of any animal, it and if it has dog in it, it will identify there's a dog. It can be used for say facial recognition as well. We can train a model to identify a particular person in different images which is getting produced. That's your supervised learning. And think of it this way, it's like student learning from a teacher. The teacher provides example with the correct answers, and the student uses these examples to understand how to solve similar problems in the future. That's what supervised learning algorithm is. Now, some of the common algorithms that you come across are linear regression, which predicts a continuous value, like we want to estimate house prices based on features like size of the house, location, or could be number of bedrooms or bathrooms in the house. Another algorithm is logistic regression, which solves binary classification problem. Like for example, we can predict whether a customer will leave a service or not, or we can solve a problem like if a transaction is fraudulent or not, or could be if a person has developed cancer or not. Then you have decision tree. This is a very easy to interpret model for both classification and regression, but predominantly we use for classification purpose. And we can use it for a problem like if a loan application is approved based on applicant details or not, should be the loan be given or not, that kind of problem. You might also come across an algorithm called neural network, which handles complex problem involving patterns or large data set. And most of the object detection module that you talk about are based on neural networks, or when you're talking about speech recognition, or you talk about text classification, we generally use neural networks for that. So these are the algorithms available. Use cases: fraud detection in banking, identify unusual transactions by learning pattern of normal and suspicious activities. That could be one example. Banks rely a lot on machine learning algorithm. Imagine thousands of transactions are happening, and if we can proactively identify those transactions which are fraudulent, we can save a lot of customers who can actually churn from our bank because their money is not safe, and also prevent some kind of suspicious activities. Similarly, we can use it for medical diagnosis. We can predict diseases based on patient record, like identifying diabetes from health metric, or could be identifying if a person might develop a heart problem in future. We can also use for marketing analytics, where we can forecast customer behavior, such as predicting who might respond to a campaign. These are the example of supervised learning, and it requires labeled data, and more quality data provided, the better the model perform at making predictions. So that's your supervised learning. The
Right.
next,
Yeah.
unsupervised learning. When you talk about unsupervised learning, is a type of machine learning that works with the data that doesn't have label. We have a lot of data points, but we do not have a corresponding output or corresponding label. The model explores the data on its own and tries to find patterns, groupings, or structures within it. So think of it this way: it's like an explorer analyzing a new environment without a map, trying to figure out the layout and relationships within it. Common algorithms include k-means clustering, which groups similar data points into clusters. Like we can categorize customers into groups based on their buying behavior. You have principal component analysis, which simplifies data by reducing the number of features while keeping the important ones. It helps us to reduce the dimension of the image data for faster processing. So when we are sending images, we can reduce the size so that we can do faster transfer of data. You have hierarchical clustering, which is another type of algorithm for grouping similar observations together. You have autoencoders, which are deep learning based algorithm, helps you to understand the inherent structure of the data and helps you to reduce the size of the data. Use cases you come across as customer segmentation, divide customers into distinct groups for personalized marketing strategies, identify high value customers or frequent buyers. You can use it for genome data analysis, discover patterns or relationships in genetic information. Finding similarities between DNA sequences could be one example. Market basket analysis, another very interesting algorithm. You analyze shopping pattern to recommend products, and it could be customer who buy bread often buy butter. That kind of relationship we can established. It is very simple to understand that people who buy bread, they will buy butter, but understand you might be selling thousands of product as a part of the retail unit, and you need to understand which two products are getting sold together, and that's where this unsupervised learning come into the picture. So unsupervised learning doesn't rely on labels. Instead of, it helps discover the hidden structure in the data, making it ideal for exploratory analysis or pre-processing tasks.
Right. Yeah.
And next is reinforcement learning. Reinforcement learning is a type of machine learning where an agent learns by interacting with its environment and receiving feedback in the form of rewards or penalties. The goal is to learn the best strategy to maximize rewards over time. So if I have to simplify it for you, it's like a player practicing a game. And through trial and error, they learn which moves lead to higher scores and which one to avoid. And if some of you are into gaming, and or if you have played any kind of video game, you will understand that you try certain moves in the game, and over the period of time you learn which set of steps you should choose so that you can maximize your score. And that's what reinforcement learning does in a real time problem. So that's what reinforcement learning is. And the core element over here, if you look into it, you have an agent, which is the entity making decision. And for us, it would be the learning algorithm itself. Environment, the external system that agent interacts with. So agent could be a self-driving car deciding how to navigate a road. An environment could be the road itself, the traffic, weather conditions for the self-driving car. So that's your agent environment. Now, actions are the choices or moves that the agent can make. Like in the car, in the example of self-driving car, it could be speeding up, slowing down, or turning. The reward is the feedback that the agent gets to indicate how good or bad an action was. Like, for example, in the self driving car, a reward for avoiding accidents or penalties for breaking traffic rules. So this is how reinforcement learning work, and their elements are. And the common algorithms you will come across: q learning learns the value of action in specific states to find the best policy. An example could be a robot learning the shortest path in a maze. Then you have deep q networks, which is extension of q learning, where we utilize neural network to enhance the performance. And we can teach a bot to play video games by learning from visual inputs. That could be an example for deep q networks. You also have something called policy gradient method, where we can it directly optimizes for the best strategy. And we can use policy gradient method for training a drone to perform aerial stunts smoothly. Use cases when you talk about robotics is something which has caught many people's eye. And training robots to perform tasks like assembling products in factories could be a pretty good example for reinforcement learning. We can also use in supply chain optimization, finding the best strategy for inventory management, routing, and delivery. It could be dynamic pricing in e-commerce, adjusting prices in real time based on demand and competitor behavior to maximize profits. So that's what reinforcement learning is. It's about learning by doing. The agent tries different actions, observes the result, and gradually improves its decision to achieve the best outcomes. That's what reinforcement learning is.
Got it. All right. Yeah.
And this is just a quick summary of types of learning. Supervised learning, what kind of data we need here? It should be labeled data. Goal is to predict outcome. So all your predictive model are part of your supervised learning. Example: spam detection, sales forecasting. Unsupervised learning, you have unlabeled data, you have a lot of data, but there's no label on top of it, no output, no target variable that we call it technically. The idea here is to understand the inherent property or the structure of the data. Examples are customer segmentation, anomaly detection. Then you have reinforcement learning, which is a reward based feedback system. It learns best course of action in a given environment. Examples are, and you can use it in robotics, game playing, AI. This is a quick summary just to understand what each one is doing.
Right. All right.
Now, next is we are talking about ML workflow, which is very important once you start working in machine learning. If you're working on a machine learning project, if you get this idea that where you start and where you end, it gives you a very good structure to your entire project. So it starts with defining a problem. You clearly explain what kind of problem you're going to solve. You can define it, you can write it as well. You can say that I want to predict who will default on a loan. That's what the problem is. And based on the problem, you collect the data. So then you start looking into the data, what kind of data a bank is maintaining, and what are the different data sources that you have. You might have some data sitting in some standard databases. Some might be you have to scrap from the social media probably, or you might have to read some flat files. So you collect the data, then prepare the data. Data might have its own issues. It might have certain missing values, erroneous entries. There might be certain outliers. You might have certain data which is not numerical. You need to work with them. So you prepare the data. Then you next stage would be that you choose and train a model. So you have a number of models available for the same kind of for the same problem. Like when I'm saying if a person will default on a loan or not, I might use logistic regression, or I can use gradient boosting machine, or I can use a neural network. And as a machine learning practitioner, you are not sure which model will work. So we try a couple of models, we see which one is working well, and we start fine tuning it. Then once you have chosen a model, you have trained it, then you evaluate your model, how it's working on the data on which it has been built, and also how it's performing on some unknown data, which we call it as test data. So we evaluate the model, and if model is working well, then we deploy and we put in the production where model is live, and on the go it is providing you predictions. You monitor it continuously and make sure that if its performance is going down, then you start looking into whether what could be the problem, and if required you retrain the model, or sometimes you do incremental training as well. So that's your ML workflow, that is starting from defining the problem, going to the deployment and improvement. Probably one thing I would like to add over here would be that alongside defining the problem, you should also gather information about the domain in which you are working, or business understanding you should get. That helps a lot in terms of preparing the data, doing the feature engineering, and also gives you the perspective that what are the underlying issues in the data from the business perspective. So that's your ML workflow.
Got it. All right.
Now, the common algorithm you should know, linear regression. It predicts continuous value. In case you do not know continuous value, we're talking about numerical values, which can take any value. Basically, we are saying, suppose when I say price of a house, it's a numerical value, and it can take any value between say 100,000 to say 500,000 in a locality. Just to give an example. Decision trees for interpretable decision making. We use it for classification as well as regression. Classification means when you're predicting a particular class. Regression means when you're predicting a continuous value. You have support vector machines, which we predominantly use for classification tasks. You have neural networks, which is idea is to imitate the human brain. And here, this is used for your deep learning tasks.
Okay. Just so one last thing about what they can do as next steps.
So, machine learning is reshaping industries, driving innovation from healthcare to entertainment. In healthcare, it helps diagnose disease earlier, while in entertainment, it powers personalized recommendations, keeping audiences engaged like never before. And your next steps, if you have to think about, if you're ready to dive in, start by exploring powerful ML libraries like TensorFlow or Scikit-learn. Practice with small, manageable data set. Platforms like Kaggle offer great options to get started. And most importantly, take the leap. Bring your first ML project to life and experience the impact of your learning firsthand. And remember, the best way to learn machine learning is to build, experiment, and iterate. Every step forward takes you closer to mastering this transformative technology.
Hmm. Yeah, that's true. So speaking of upskilling and also, making your first project live, let us know what is exactly stopping you from pursuing a career here, or what is exactly hindering you from, taking up your next opportunity. So I'm just launching a quick poll again, and yes, we've got some questions from the YouTube audience. I'll pass that on. But people watching us on Zoom, if you guys have any more questions, please keep adding them on the Q&A box. So yeah, and also, of course, answer the poll that I've launched. Just let us know what you feel is stopping you, whether it's a curriculum, whether it's your inability to learn from recorded lessons, or just that your work schedule doesn't allow, or you don't have practical exposure, right? So this is where, of course, our courses are focused on giving you a curriculum that is proven to help you gain all the necessary skills in this particular subject, along with giving you access to practical exposure. We'll talk a little bit about the course while you guys are posting questions on the Q&A box. So remember that this course is in collaboration with Purdue University, and we also have modules from IBM, right? So I don't think we need to really understand how Purdue University adds value, or the credentials, how they are going to be giving you that recognition from employers. So it is, a certificate that is valued across, across various employers and across domains, basically. So along with whatever you get from IBM and from Purdue, you get hands-on experience in terms of projects and also learning these tools with the help of the trainers that you have. So let me just take you through the course very, very quickly. So remember, this is called the Postgraduate Program in AI and ML, and we've done this in collaboration with Purdue University and IBM. So your applications close in the next couple of weeks, but you still have a couple of weeks, yes. But try to finish in your application because there's a certain criteria that you are required to fulfill. So you will need a bachelor's degree, some understanding of maths, statistics, and programming. But of course, it's not mandatory, but it helps the course if you have. So more on the curriculum in some time. This course is 11 months long. Someone was asking about our other programs. You also have other programs in AI and machine learning, just to give you a quick snapshot of what we have, right? But the focus here is this particular program. And let's say you are interested to know more. Yes, all of you have actually said you guys don't have practical exposure, right? So let us show you how this course gives you the practical exposure. So Amitendra, I'm just going to, yeah, this is the curriculum. So if you can take them through the curriculum and help them understand how that bridges the gap and how it's an extension of what we exactly covered today. So if you can just explain the curriculum to our learners.
Sure. So when you talk about machine learning, in particular, and you want to gain understanding of how do they work, you need to understand that you need to learn Python for sure, because that's the language that is generally used for machine learning algorithm. It has a huge demand. So what we are doing here is we are starting with a programming refresher, which gives you the idea what programming is all about. Just a refresher gives you the understanding that what is coding, how does it work entirely, and how it's going to help you in machine learning algorithms. Then next we move to Next, we move to Python for data science, which is basically helping you to understand what Python libraries are helpful in data science or machine learning that we talk about. So here we are discussing those modules which will be helpful to create those data pipelines or machine learning pipeline, or eventually when you want to deploy your model, and how Python helps you with that. So this is where you'll be learning different libraries, how to work with the data with those libraries, and eventually correlate all this with the machine learning project that you're gonna work eventually. Then next is applied data science with Python. This is where we start discussing about that when you want to build machine learning algorithm, what kind of inputs are required and how do we ensure that the data that has been given to you, you clean it, process it, and then make sure that it converts into such format which is suitable for your machine learning. So here we discuss about data aggregation, summarization, feature encoding, like how do you transform a text data into a numerical representation. If required, how do you reduce the size of the data? What are the algorithms for that? So that's what you will learn over here in applied data science with Python. And again, Python will come handy in terms of carrying out those kind of analysis, like I might do a principal component and analysis to reduce the size of the data. And when I want to do it, I can call Python to run on the data, those algorithms, and give me the result, and I can analyze it. Once this is done, you will move to machine learning. Now, machine learning is where we will be focusing upon machine learning algorithms. And we discussed about, like, you have to understand about what is linear regression, what is logistic regression, and so on. Now, what we do over here is that we explain you what algorithm is. We give you the entire mathematical intuition behind it, which is very important to understand. And we give you a bite size learning over here. We explain you in a very simple fashion that how the algorithm works. We do not complicate things over here. And after we explain you how machine learning algorithm work, we pick up a data set and teach you how to implement on a given data set. So what we do here is we provide you certain notebooks as well, Python notebooks, which comes with the entire implementation. We explain you line by line what we are doing, and then we give you some case studies to work upon so that you can reinforce your entire learning that you have done on that algorithm. That's how the entire program on machine learning will go. So that's your machine learning. Then you have deep learning with with TensorFlow, and this is where we start talking about how you build neural networks. And TensorFlow is the main library you utilize for neural networks. So you will be taught different kinds of neural networks that you can create. It could be convolutional neural network, it could be RNNs, it could be simple autoencoders, it could be simple neural network that you are building. So that's what it focuses upon. Then next is deep learning specialization, where we take that learning to the next level and we talk about some advanced deep learning concepts. We also discuss over there your transformer architecture, which some of you might have heard, which is the backbone of your chat GPT or any other LLM. So we discuss what are the different advanced algorithms which are available as part of your deep learning concept, and we discuss that in detail. Again, the idea is that we explain you the concept and then we implement on the data. Then you have essentials of generative AI, prompt engineering, and chat GPT, which is very much in demand these days. So we discuss about what is generative AI, prompt engineering. Then you have a capstone project, which is basically giving you and it basically tests your knowledge on the entire module that you have gone through. It's a comprehensive capstone which will go through all the problems that you have heard in the classroom, you have solved, combine them together, put across in a form of a capstone project, and it tests your knowledge on different
Got it.
modules that you have gone through. Then in addition to that, you have electives as well. You have academic masterclass by Purdue University online. You have masterclass by IBM. You have advanced deep learning, computer vision, NLP and speech recognition, reinforcement learning, advanced generative AI. These are the electives, and you can choose one, or actually you can choose more than one as well. So that's the whole program that you have.
Got it. Thanks, Amitendra, for taking us through the curriculum in detail. In case someone wants to really understand whatever Amitendra has explained, you can check out the link on the chat. I have switched off the chat box so that the link stays. You can download the program syllabus, and all obviously we have covered the curriculum in detail. So it's very similar. So whatever tools are particularly applicable to that module, you will be learning them hands-on along with doing these industry projects. So your trainers and your peers will also be there for you to interact with, exchange ideas, get your doubts answered, and all of that. But let's say you have queries regarding your progress or accessing the course, you will have 24/7 support from our learner success team, right? So you can take a look at these success stories as well, and also take advantage of the Simplilearn Job Assist program. So we've got a partnership with IM Jobs, and you get a pro membership free. This is for the India learners in India. But if you're living in the US, we have partnered with Talent Inc. for the same purpose, for the Job Assist program. So what happens here is we help you with resume writing. We help you get your profile highlighted with the recruiters that you may want them to notice. Okay. So this is just a quick brief about the course, and anything else that you want to look at, feel free to go to the course page and check out whatever details you want to. And also we've launched a poll asking your interest in the course. So you can expect a call in the next 12 to 24 hours. And of course, whatever you see here is the fee in India. And yes, there are also discounts that run in, and you might want to reach out to a learning advisor and ask them about what is applicable right now and use the best possible opportunity in order to enroll the course. Yeah. So like I said, you have a couple of weeks to fill in your application. So it's just a very three-step simple process where your application is given. Once that's done, it's scrutinized by the admissions team, and then you start learning after you've received an admissions letter. Okay, so that's just a quick summary of the course. Let me take a look at the Q&A. So any certificate related questions, remember you will get it soon, very, very soon. We've already prepared them and you should be receiving them tomorrow. Okay, Tosif, thank you so much for pointing that out. Job assist, for what duration? It is a part of the course, Pooja. So as long as you are in the course, you get access to the job assist program. Pooja has a question, Amitendra, the difference between business analyst and data analyst.
Yeah, the business analyst and data analyst have distinct focuses and responsibilities. Business analyst focuses on understanding business needs and bridging the gap between business stakeholders and technical teams. They are involved in process improvement, business requirements, and strategy. Data analysts, on the other hand, they focus on analyzing and interpreting data to provide insights. They work primarily with the data sets to solve specific problems or answer questions. In terms of tools, if you talk about, analyst will work with the project management and documentation tools, like you might have heard of Jira, or you might have heard of Microsoft Visio, Lucid Chart and all. They might use Slack, Zoom, and they might do some basic data analysis with Excel, or probably to a certain extent SQL. Data analyst, on the other hand, they will be utilizing some data analytics tool, like they might use Tableau, Power BI, they might use Python, or databases. They can work with different kind of databases. They might pick up some statistical tool also like SAS R and all, and they analyze the data. So that's what predominantly the difference is between the business analyst and data analyst.
Got it. Great, great. So is AI and machine learning important for a mathematics student? Tausif has this question.
Well, I would say it's other way around. Mathematics is pretty much
Yeah.
important for AI ML.
Yes. Okay, so just to quickly address this question about certificate, guys, remember I told you in the beginning that you will receive the certificate on email and we'll collect the names towards the end. So please do not post the same question, and you guys have access to the Q&A box, so you know who is posting what. So make sure you see what is getting answered, and and remember the certificate is just a proof of attendance. You gain value by asking questions and learning. So let's get some more interesting questions here. Now that Tasif's question is answered, so Pooja again wants to know if Power BI is learn. Okay, is Power BI part of this course? No, Power BI is a part of our data analytics course. Pooja, not really this course. So is Python the best programming language for AI? That's another question that we've got.
At the moment, it is like that. Python is the go-to language, and because of the support that we get for different kind of algorithms, and it has become the most sought after language for machine learning and AI. In fact, you can say that it these days it's like the moment you talk about machine learning or AI, people think of Python.
Yeah, yeah, got it. Uh, It's like programming in English. How is data analyst different from an ML engineer? That's another question.
Okay, when you talk about data analyst, and I think data analyst, I was just explaining what they are doing in terms of what their job role is. So data analysts primarily focus on interpreting and analyzing historical data to extract insights, trends, and patterns that can help inform business decision. That's what we want to do. Now when we're talking about machine learning engineers, okay, so machine learning engineers, their deliverables are totally different if you compare with the data analyst. So what happens with the machine learning engineers, they focus on designing, developing, and deploying machine learning models and algorithms to automate processes, predictions, and decision making system. So probably a data analyst is focusing upon finding the certain insights, certain trends, and that's where its job ends. It can simply help businesses to make some informed decision or help them to build some strategy. Machine learning engineers, on the other hand, they are focusing on creating certain applications which will utilize machine learning models at the core of it, and making sure that it is deployed and maintained throughout its life cycle. So that's what the difference would be. And the 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 tools that they work with is quite, tools will probably overlap with what data analysts are they are using and what machine learning engineers are using, but their end goal is totally different. And most of the time you will come across that data analysts don't won't even work with the machine learning algorithms. They will predominantly work with the basic data analysis. And machine learning engineer, for sure, they will go through different kind of algorithms, different kind of machine learning libraries, certain automation tools. So that's what the difference is.
Got it, got it. So just one more question, Amitendra. It's a slightly technical question about supervised, unsupervised learning. Someone wants to know what technology or what kind of learning do self-driving cars utilize? Are they primarily an example of supervised, unsupervised, or combination of both learning approaches? And if, I mean, they just want to understand what's,
Generally, it's a combination of supervised learning and reinforcement learning. Supervised learning will help them to, like, when a self-driving car is receiving certain video feeds, our job is to identify what objects are there in that video feed. So we need to have a supervised learning algorithm over there, which will tell the car that there is a pedestrian in front of it. But reinforcement learning will ensure that car learns over the period of time that if there is a pedestrian, it has to slow down, it has to stop. So it's a combination of supervised learning and your reinforcement learning.
Got it. Got it. Got it. Someone is asking, I think, a lot of similar questions today. How should one know about ML for data scientist job? How much of ML should a data scientist know, especially if it's a fresher? How should they exactly go about? I mean, we are getting these questions a lot today as to how to start if they want to become an ML engineer from, whatever job role they're in now.
Okay, one thing I want to tell you very clearly that as a data scientist, if you want to work, you have to know about the statistical analysis and machine learning algorithm end to end. There's no
Right.
question about it that you can just learn 4, 5 algorithms and you can say, no, I'm ready. It doesn't work
Mhm.
that way. You have to learn all the algorithms. You need to learn what's the advantage, disadvantage of each one of them, and what are the actual problem you face when you're working with a particular algorithm. What are the basic use cases of those algorithms? So you cannot run away from those aspects. You have to learn each one of them, and then only you can say that now I can apply for a data scientist job role. And that's why any of the program that we run, we cover all those algorithms.
Right. Got it. Got it. I think that answers your question, I guess. Um, so Tosif has this question, what is exactly the disadvantage if you're depending on AI? Is it good to use AI tools? I know it reduces time, I think. So yeah, maybe you can.
Say, I'll tell you, disadvantage probably we are over relying on any kind of tool is not good for us. Like, it could be as simple as when the calculators came, people stopped using their own brain for any kind of calculation. And even when they have to do a simple 15 plus 17, you go to a small shop, they will pick up calculator and they will do it. So over reliance on any kind of technology is not good for human being in general, I would say. And you might have also seen that although AI brings a lot of utility for you, but at the same time, a lot of fraud also happening because of AI. A lot of issues are coming in terms of ethics and the practices that we talk about. So it has its advantage and disadvantage, but whether you like it or not, it's gonna be there, and you have to just learn how to utilize it for your own productivity.
Right. All right. All right. So we'll take another question from Milind. He says, how do I know that the data I have for my company can be used for ML? How do I know and when can?
It's, I would say that that becomes a very difficult problem in a sense that when the client tells us that here is our data, tell me what you can do, it becomes a very vague problem in a sense that I can come up with hundreds of things, and the client might not be interested. Why I'm saying that is because you might have some data, but you need to understand what stakeholders are looking for. I might have some mechanical data belonging to cars, might be trucks or buses that my client is running. And I might say you can do this or that, but if it does not add any value to them, then there's no purpose of doing that analysis. So I would say that data is fine, you have the data, but whomso is a stakeholder, whomso that data belongs to, sit with them, identify the pain areas, and then you start thinking how a machine learning algorithm can help, rather than other way around that I have the data, what all I can do.
Got it. Someone asked a question on job. I have just typed it, and sent it to them. But the question is, how can one build the skill? Obviously, upskilling is an option. But how does one build a portfolio, and how does that help in eventually, cracking an interview or finding a job?
See, what is happening is when you go for the interview, the main thing the organizations are looking is that you can take a problem and you can solve it. That's what they want to know basically. And mere learning the algorithm, you might say that I know how it works. I have done some small case studies, but eventually in the interview you will fail because it will come out that you do not have thorough understanding of what to do in the entire problem. So what I would suggest is that pick up the case studies, pick up from Kaggle or any other places, start solving it, see what other people are doing it, what improvement you can do an iterative process of trying to build multiple models or fine tune the model. So over the period of time, you will learn that what kind of problem you came across when you were building the model and how did you overcome that. And
Yeah.
also once you have reached to a certain level of model accuracy, how did you beat that. And once you start gaining experience on that, then in the interview, you will be able to project yourself that you are somebody. If given this problem, you will be solving it end to end. And that's what they're looking for. And that's why you should build the portfolio. You should showcase that this is what I have done over the period of time. For
Mm.
each case study, each project that you are talking about, you should talk about what was the problem, what were the issues you faced in the project, and how did you solve it.
Yeah, got it. Got it. Got it. So what's the difference between a machine learning engineer and an AI engineer? We've done this webinar a lot of times, but you can maybe explain. Someone also asked AI and robotics. I know they're not the same, but maybe you can just highlight the key differences of all three fields.
Okay, ML engineers, AI engineers, again, focus is different.
Hmm.
Uh, ML engineers focuses specifically on the development, training, and deployment of machine learning models, which I told you earlier also. They work with the algorithms, data pre-processing, model optimization to create system that learn from the data.
Hmm.
AI engineer is a broader role that encompasses various subfields of AI, including ML, natural language processing, computer vision. You bring robotics there, expert system. So AI engineers often build intelligent system that can mimic human decision making, perception, and problem solving across a wider range of tasks beyond just machine learning. So probably just think of it as a broader role, which is where you can think of somebody has evolved from ML engineer to become AI engineer, where they are actually looking for solution which is beyond machine learning. That's what you can think of. Okay.
Got it. And one very basic question, I think it's the right question as well. Does training a model always require a high-end processor, or can they use, the personal laptop itself?
Not really. It does not always require higher end processing. It depends on your data and generally kind of problem you will come across. Your normal laptop would be sufficient. And for probably for a deep learning algorithms, you can simply buy a laptop with a GPU, and generally try to buy your NVIDIA based GPU because you have most of the libraries support that. That will be sufficient until unless you want to work with some LLMs, large language models, and you don't want to utilize any of the API, but you want to work with your own application that you want to build with some open source LLMs. So then you need high end systems.
Understood. Great. I think I've just launched a very quick poll asking your full name, so please do that. Enter your full name, and this is for the purpose of the certificate that most of you had requested. So please make sure your full name is entered with correct spelling and it's entered in the appropriate format. So if we have any more questions, we're ready to take them. And remember, if you gave a yes on the poll, you will be contacted. And any questions that you have about the different aspects of the course, you can certainly get them answered. Um, but I think we're pretty much done here, and just wait around for a few more minutes while we finish the poll. And let's say you guys have questions, you can use them. And towards the end, you will also receive a rating service. So just make sure you rate your experience in this webinar. And also, if you would like to join us for further webinars, you can just keep in touch through our emails that we send, or we also have a WhatsApp community where we send these alerts, right? So we'll talk about this just in a bit, but let's finish entering your names. Yeah, I'll give you another 30 seconds only. After that, we'll have to close the poll. Asif, this is not for the YouTube users, unfortunately, only for people on Zoom. So on the description, on the video description, you will find the link to the WhatsApp community. You can join there to receive alerts on our further webinars. Yeah. Okay, great. Thanks so much, guys, for entering your names. Now, quickly give us your rating for the webinar and let us know what we can do better. Okay. And someone who is still wondering about what community I am talking about, I am sharing this link on the chat. You guys can join the WhatsApp community. Here, just a moment. I think I shared the wrong link. Yeah, that was the course page. This is the WhatsApp community. Just join us there and you will understand. On the day of the webinar, you will know the alert and the link will be shared on the group. Okay? Great. Great. But any closing thoughts, Amitendra, before we end here?
I would just say that if you have decided to start your journey, get on board, and I'll see you all in the sessions and we'll take it forward.
Yeah, yes, yes. All right. I think it was wonderful hosting you guys today. Thank you so much for your responses as well on all the polls, including the one on rating. Most of you liked the session, so it's just motivating and also, nice to see all your enthusiasm with the questions that you've been asking and the curiosity that is there. Great. Thank you so much, Pooja and everyone else, Mika, Samuel, everyone else who participated in the Q&A box. Thank you so much for joining in, the others as well. We'll see you in another session, and thanks.